And welcome to Miss Riley's Maths videos. Miss Piggy is joining us here for this particular video, and what I'm looking at today is quadratic sequences or quadratic patterns and how to find Tn, which is the general term of a quadratic sequence. So I have a sequence here and I'm going to show that the sequence is quadratic. I'm going to find the second term or the second difference. I'm going to show you how to find the general term Tn, and then we're going to find the 20th term. Okay, now there's a couple of different approaches to this, so I'm going to try and show you two different approaches. They're actually quite similar, but one is a bit more visual than the other, so we'll see how we get on. So here's our sequence that we're given: 11, 18, 29, 44, 63. Now, as you may know, the easiest way to decide what type of sequence it is to first of all see whether it's a linear sequence, which is sometimes called an arithmetic sequence, and we look for the difference. So how do we get from one term to the other? So 11 to 18, the gap is 7. 18 to 29, the gap is 11. 29 to 44, the gap is 15. 44 to 63, how do we do it? That's a gap of 19. I just changed the lighting here to see whether I can get rid of the shadow, which I have. Okay, so this is called the first difference. If this was a linear sequence, then the first difference would be the same each time. It would be constant. The first difference is not constant, so it's not a linear or arithmetic sequence, as first difference is not constant. Okay, now, is it a quadratic sequence? Well, if it's a quadratic sequence, then the second difference will be constant. In other words, the difference of the differences. So here's a gap between the differences of 4. Here's a gap between the differences of 4. And here's another gap. So we can see that the second difference is constant. So this is a quadratic sequence as the second difference is constant. And that's equal to 4. So we've shown that this sequence is quadratic, and it's enough to do that. The second thing is to find the second difference. Well, we've done that. So part 2 is second difference is equal to 4. Now part 3, to find the general term. The thing about the general term, there's a couple of things. First thing is that often you're given, just moving that down, to find the general term, often you're given the kind of the structure that you need for the general term. The structure is that the general term, which we write as Tn, which is sometimes called the nth term or any term, okay? The Tn, the general term, which is the rule for that particular sequence, is in a quadratic sequence, it's got this form: an squared plus bn plus c. What that means is it's got a squared term, it's got an n term, so an n squared term, an n term, and a constant. Now, it may not actually have an n term or a constant, but it will definitely have an n squared term, because you recognize that squared bit as meaning that it's quadratic. So sometimes you're given this, and sometimes they expect you to know it. I think in junior cert, in higher level, in the exams, they will give you that. But just in case, try and remember it. Now, another useful thing to know is that a value there, it's the second difference divided by 2. Now, to be honest, I sometimes forget that, and it doesn't matter because there's other ways of finding it, and I'll show you why in a second. But if you remember it, a, the number in front there, is the second difference divided by 2. So in our particular sequence, a would be 4 divided by 2, which is 2, which means that our general term is going to be 2n squared plus bn plus c. But again, sometimes that's, something in the middle of an exam or the middle of a problem, you might forget that. So is there another way we can do that? So what I'm going to do here is I'm going to take our general structure, Tn is equal to an squared plus bn plus c, and I'm going to take our sequence that we've been given, 11, 18, 29, 44, And I'm going to try and match these two side by side and see what we can notice and what we can use. So this is for any quadratic sequence, whereas we're dealing with a specific quadratic sequence. Okay, and we've already seen that in our specific quadratic sequence, the first difference is 7. Okay, so let's see in this general quadratic sequence, what would the first difference be? So that would mean we'd need to find T1. Remember, that's T1, that's T2, and that's T3 and T4. So let's find out what T1 would be. Do you notice where the 1 is where the n is? That means wherever there's an n, I'm going to put 1. So T1 is a by 1 squared, which is a, b by 1, which is b, and c. Okay, T2 is equal to a by 2 squared plus b by 2 plus c, which is 4a plus 2b plus c, and T3 is a by 3 squared plus b by 3 plus c, which equals 9a plus 3b plus c. Now what I'm assuming at this stage is that we've forgotten that a is already 2. Okay, the reason I'm doing that is because I don't like relying on remembering a specific fact like that, and I'm going to see is there another way that we can do it. Now let's see what we have. Let's write out this and see whether it can help us. So T1, maybe if I do it underneath here it might actually work. T1 is equal to a plus b plus c. T2 is equal to 4a plus 2b plus c, and T3 is equal to 9a plus 3b plus c. I'm just getting those from over here. Do you see that? Now, what's the difference between T1 and T2? The difference between T1 and T2, well, to get from a to 4a, I added 3a. To get from b to 2b, I added b, and I didn't add on any c's. They're the same. Okay, so the difference here is 3a plus b. Here, to get from 4a to 9a, I added on 5a. To get from 2b to 3b, I added on b. And to get from c to c, I didn't have to do anything. Okay, now let's just do one last thing. Let's find the second difference. So this is the first difference, and this here was the first difference. Now, here, the second difference is the difference between those two. So looking at that, 3a to 5a is add on 2a. b to b, I don't have to do anything. So the second difference is 2a. See, this is where the rule comes from that we talked about a minute ago. Here, the first difference is 7. Oh, what did I? You should have told me there to stop. That's 11, and that's 15. Sorry about that. If you're confused, now you're less confused, I hope. That's a difference of 4, and that's a difference of 4. So the second difference is 4. I'm not going to go back and redo that, but hopefully now you've stuck with me and you've seen the second difference is 4. Now, I now know the second difference is 2a, but I also know that the second difference is 4. So there's my information that a must be 2. Do you see that? In this specific sequence I'm working with, the second difference is 4. In this general sequence I'm working with, the second difference is 2a. They're both the second difference, so they both must equal each other. Let's write that second difference. So a must be 2. Now, what else do we know? We know that 3a plus b is the first difference between T1 and T2. Let's see, is there a comparable thing here in our specific sequence? There is. Look, the first difference there between the first two terms is 7. So 3a plus b, which is the first difference between the first two terms, must be 7. But we now know that a is 2, so 3 by 2 plus b equals 7. So 6 plus b equals 7, b must be equal to 1. Now we're nearly there, look. Okay. So we now know that a is 2 and b is 1. Now, we've got to find c. Let's find an equation that has c in it. Here's an equation that has c. T1 is a plus b plus c. And that equals T1, but that also equals 11 in our specific sequence. But I know a is 2, I know b is 1, and I don't know c, and I know that that equals to 11. So 3 plus c is equal to 11, so c must equal 8. So what do I have? I have that my general term for this arithmetic sequence, Tn, which was an squared plus bn plus c, I now know that for my specific sequence, that equals to a is 2n squared plus bn, which is 1n, plus c, which is 8. In other words, it's 2n squared plus n plus 8. That's my general term. And how would I find T20? Because I was asked to find the 20th term. T20 is equal to 2 by 20 squared plus 20 plus 8. So what's that? 2 by 400 plus 20 plus 8. So that's going to be 828. The 20th term of that sequence is 828. So maybe that works for you. I'm going to show you the other way to do it, just in case it helps. And it's very similar. It's just using simultaneous equations instead. I think this is the easiest way because it's visual, but you may find that you prefer the simultaneous equations. So let's just go to a page. So remember what I had was my sequence is, let's find it again, 11, 18, 29, 44, and 63. Okay. My first difference is 7, here it's 11, here it's 15, remember I got this wrong last time, here it's 19, that's my first difference, and then this is a difference of 4 for my second difference. And remember I said T1, well Tn is an squared plus bn plus c, T1 is a by 1 squared plus b by 1 plus c, which is a plus b plus c, T2 is equal to a by 2 squared plus b by 2 plus c, which was 4a plus 2b plus c, and T3 is a by 3 squared plus 3b plus c, so 9a plus 3b plus c. Okay. So what do we know? Looking at this, T1 is equal to a plus b plus c, and that equals to 11. T2 is equal to 4a plus 2b plus c, and that equals T2, which is 18. And T3 is equal to 9a plus 3b plus c, and that equals 63. No, sorry, that equals 29. Okay, so what I'm going to do is do simultaneous equations in 3 unknowns. Now, obviously, if you remember that the second difference 4 is twice a, then you could already get that a is 2. But let's assume you don't remember that. Okay, and let's just work as if you don't. When I'm doing simultaneous equations in 3 unknowns, what I do is I go about them the exact same way. I eliminate a variable each time. So what I do is I look here and see, can I eliminate, take 2 equations at a time, can I eliminate one of the letters? So looking at this, I think it would be easy to eliminate the c. So I'm going to multiply the first line here by -1. So that'll give me minus a minus b minus c equals minus 11. And this is 4a plus 2b plus c is equal to 18. I add those two together and I get 3a plus b is equal to 7. Okay. Now I'm going to take these two together, b and c, and also eliminate the c. So b is equal to 4a plus 2b plus c is equal to 18. And if I do minus 1 times c, I get minus 9a minus 3b minus c is equal to minus 29. If I add those two together, I get minus 5a minus b is equal to minus 11. So I now have 2 equations with 2 things I don't know. One equation is 3a plus b is equal to 7. One equation is minus 5a minus b is equal to minus 11. I notice that if I add those two together, I can get rid of the b's, so I have minus 2a is equal to minus 4. Divide by minus 2, I get a is equal to 2. Well, that's positive. I've now got 2 things. Well, I've now got one that I know, and I've got an equation I can pop it back into. 3a plus b is equal to 7, because remember, it's simultaneous equations. Once we get one of the values, we sub it back in. 6 plus b equals 7, so b equals 1. I now have what b is, and now I pick one more equation, maybe the first one, a plus b plus c equals 11, I know that A is 2, B is 1, C is 11. So 3 plus C is equal to 11, so C is equal to 8. So what did I do there? I wrote my 3 equations and put them equal to the first 3 terms. I used simultaneous equations elimination method to eliminate the C's. I multiplied this line by -1, added the 2 lines together, same size, opposite signs, they cancelled each other out. 3a plus b equals 7. Then I had line B and C, and I took them together and eliminated the C's. So what I ended up with was 2 new equations that had just A and B, no C's in them. I was able to solve them using simultaneous equations. I found out what A was 2. Then I could find out what B was by subbing A back in. Then I could find out what C is. So now I have the same thing, whereas I have Tn is equal to an squared plus bn plus c. So Tn is equal to 2n squared plus n plus c, which was 8. And that's my general term. Okay, I hope that helps. Talk to you soon. Bye-bye.